Okay, Mahesh, good to see you here. Thank you
Well,
so much for joining.
well, thank you for inviting me.
Yeah. Folks, we had fiber mobility so far in the discussions, a few sad discussions as well. This is the new avatar of connectivity. So we have Mahesh here, and we say telco is born out of physics. So we have seen most of the evolutions since yesterday as well in the discussions. So would love to hear what the technology looks like at your end, and maybe some bit of your background as well, Mahesh, as a tee up
Sure.
to the team.
Many of you might have heard about Project Loon, which was our balloon powered initiative. And I was working on Project Loon. And at that time, we thought we are trying to put cell towers in space using these balloons. And these balloons would be at 20 kilometers up, twice the height of commercial airplanes, but they need to talk to each other. And that technology, you can draw fiber from one balloon to the other balloon. So we ended up actually coming up with a free space optical communication concept. It's not really a concept, it's a technology that's been around for a while. But what I did was, rather than having the balloons talk to each other, what if we were to take that same technology and put it down on the ground, literally take a bucket and pour concrete on it and start connecting people? So you can, I know you had fiber here, but we could provide the speeds of fiber but with all the flexibility of wireless without having to dig or trench or lay fiber. And you don't have to worry about spectrum licenses. This is unlicensed light domain. And we started out in India, working in Andhra Pradesh, and now we've been scaling it and now live in 20 countries, serving hundreds of thousands of people behind each one of these.
No, it's fascinating. And what about your journey as well, Mahesh, personally? So how have you evolved?
Yeah, I mean, I grew up in a middle class family in India, and it was um challenging to let alone computers. We didn't even have a TV at home. So the very first time I had access to internet was in a internet cafe using a dial-up modem, trying to search for universities in the US. But that moment completely changed my life. That I could sit thousands of miles away, but yet look at all the universities and look at the pictures, look at the life. And that inspired me to say, like, if I am so inspired, how many more people are there that could be connected? So since I moved to the US now, I can't even remember. It's been like 30 plus years that I've been in the US. And I've made it sort of my mission to try and provide connectivity to everyone. And in many sense, that became the journey where, like, I think there is a better way of solving the connectivity challenge rather than waiting for fiber and waiting for RF. We can actually solve this now, and we can change the world faster. So that's been my journey. So they call me sometimes the connectivity guy, sometimes they call me the laser guy. But it's fundamentally started with a challenge from my dad, who said every time I go back to home in Chennai, they would ask the simple question. I would fight over my dad for the internet access, and at that time it was using a dongle. So if he's online, I can be online, and it was this fight, and I was very frustrating. So he said, like, well, you're working on connectivity. Why don't you do something about it rather than complaining? So I went and spoke to a whole bunch of ISP operators and others, and that's when I realized that there's a better way of solving and understanding what the real challenges of connectivity is. Inspired me to figure out alternate solutions. So that's sort of been my journey.
No, that's phenomenal. You've challenged the status quo. We all believe connectivity requires spectrum. It requires going through the trenches. And here you have evolved something that is completely free format. So incredible. Also about tell the audience about the market as well. One emerging markets, high density spaces. It was fascinating what you're doing with another telco in the New York space. So would love to get perspective for this audience as well. How do you see it from your lens?
So the question is specifically about telco market.
Yeah.
Yeah. Um, it's ironic trying to do a startup inside a big company, and they gave me the opportunity to do this. But one of the challenges, though, was there are so many people that they're serving already the telco market. And here I am trying to do something a little bit disruptive into the telco market. So there was always a friction on how do you actually approach the telco market. So I steered away from the telco market and focused on rural connectivity, taking connectivity from urban cities and extending it to rural parts of India. But then the telcos approached us and said, wait a minute, you can actually do something even more incredible for us. We are currently stuck with 4G connectivity and we want to roll out 5G. 5G requires a lot of bandwidth, and most of the towers are not fiberized. So, what do you do? Well, you can keep on adding more microwaves. In fact, I have a demo here. Um, this is what you see as a typical um, tower anywhere in India or anywhere around the world. And this little tower is a representation of all the backhaul and the connectivity needs that is necessary. So you have a microwave capacity, which is probably able to do 500, 400, maybe a gigabit per second. And when you run out of capacity, you add another one. When you run out of capacity, you add another one. And when you run out of the tower space, then you actually add another tower. And then you keep on repeating and rinsing. But what if you can actually replace all of these with just one small little thing? That's the white part. That's the terminal. It is actually not to scale. It's so much more smaller, but we had to make it bigger so that people can see what it is. Um, it is very lightweight and it only weighs about 14 kilograms. And you can easily put this up, and it has 20 gigabits per second of bandwidth bidirectionally. So you can provide all the connectivity needs for this entire tower and maybe a few more towers right next to it and never run out of bandwidth. So this has become the basis by which telcos and operators around the world have started to use our product to deploy and fiberize effectively all their towers to deliver 5G connectivity. We started working with T-Mobile not only for just tower-based connectivity, but also for special events like the Coachella, as well as the Balloon Festival and US Open, or even the Times Square at New Year's Eve. And it's just been an incredible partnership to see how telcos are looking for ways by which they can adopt this new technology without having to dig and trench and lay fiber. And the best part is all of this radio frequency requires radio frequency spectrum license. You don't need that with our technology. And they all consume hundreds of watts of power. The number two consumption of power in India is cell towers. That's how much diesel goes in just to back them up. We can do all of those 20 gigabits per second for less than the energy of a light bulb.
This is phenomenal, first of all. So urban and dense, the Coachella, event base, rural spaces, not reached. How about the ports and the business side as well? Is there a focus there for you as well?
Yeah, we just launched a new product. It's called Lightbridge Pro, which is the next generation of that, and it's carrier grade, and it allows us to provide enterprise connectivity when you're waiting for fiber or you can't have enough capacity on your RF. So ports, mines, special events, these are all very, very easy for us to do, and even disaster recovery solutions. So every time there's a natural disaster or there is a war-torn zone, we get called in because it is very quick to deploy. We can set this up in just a matter of hours without having to wait for years for fiber to come. So that's the other advantage you get with this. And so it opens up a plethora of other opportunities as well.
And see, since yesterday, the biggest topic has been machine to machine. The future of workspace, home space is going to be different. So how do you see playing a role there as well?
Well, innovation is sort of in our DNA, and we sort of followed history's arc. History's arc has always been things in the innovation space start out bigger and bulkier, and then eventually they become smaller, but also more capable. Like, for example, we had computers the size of a room, and we had landlines, which then became cell phones, and it's both wired as well as wireless. What we have now done over the last few years have been innovating internally, now outside as well. We have taken some of the core components of that technology and we have shrunk it down to the size of a chip, the size of my fingernail. And it can transmit, receive, and steer light at 25 gigabits per second to start, but then eventually hundreds of gigabits per second. So now when you have something that is this small, with some fiber coupling or some coupling that needs to be done to transmit and receive data, you can start to put it into machine to machine robotics on all kinds of ways. In fact, one possible solution could be to put it in lights, so Li-Fi instead of Wi-Fi. So you can actually have effectively terabits per second communication enabled just using light without having to worry about interference, spectrum, or any of those challenges. And that's exactly what we are working on. And machine to machine communications is going to be the way it's going to go forward. In fact, the rate limiting step is going to be human beings communicating with each other. Already, we have AI agents talking to AI agents. In fact, funny story, I told my assistant to go schedule a meeting, and she didn't realize she was talking for a week with an AI agent on the other side. And that is what is going to become the norm, where everybody's AI agent is going to be talking to each other, and those machines don't get tired. They can transmit at very fast speeds at very low latency, and that's what we're going to need is communications. But it also has to be wireless. You can have all kinds of machines wired up, be it robots or be it self-driving cars. So we see enormous applications for this new platform that we just launched today or yesterday to be part of that future.
Wonderful. Good to hear that. And how do you see, Mahesh, the ecosystem play as well? We both discussed last week on the go-to-market, how you go into the enterprises, small enterprises. So how do you see pairing up with telecoms? You talked about one of the operators for events, but do you see it as a trend you want to follow along with them?
Yeah. So the ecosystem is not just telcos alone, it's everything that you need to provide a seamless connectivity and experience to the end user, be it at home or be it at work. So we are trying to build products that basically enable us all the way from our current generation to the home, making it smaller, better, faster, cheaper, and more efficient. And I think telcos is going to be one key piece of the puzzle where we are going to have to partner with them for middle mile, also into the last mile to serve the users. We are currently not an operator, so they have all the billing and all the relationship. We are not a fiber operator, so we need to work with them to enable and give them the tools and the technology to make that happen. But it's also our supply ecosystem. It's also our partner ecosystem, and we've been working with Wipro for almost a year and a half now, and you guys are helping us build a whole lot of our code base that's going into these terminals. So it's an incredible thing. So the ecosystem plays a very critical part. We can do it all by ourselves, but it's really the partnerships that make it all happen.
Wonderful, wonderful. And looking into the future, 2 to 3 years, where do you want to be?
Yeah, so I think this is going to be a sea change. What we have just announced is a slew of products, which is not only solving today's connectivity needs, but the technology that we're building is so future proof. It's beyond 6G, beyond 7G, in fact. And so we are skating to where the puck will be, where most of the links that we have deployed around the world, we are only seeing 5 to 10% utilization. So we have 90% excess capacity on all of our links. So we see a world where it's going to be data hungry. Cities are going to continue to keep growing, and AI is going to basically keep driving more and more of this communication demand. And we think that there is an incredible opportunity for us to play a key role, not only providing that high speed connectivity, but also in low latency. In fact, we have one of the lowest latency because you're transmitting at the speed of light over the air. So nothing is faster than that. So you get that physics advantage at a low power, and we're doing it all wirelessly. So no more digging, trenching, and stuff like that. So when it comes to enabling 2 to 3 years from now, we see this becoming part and parcel of many of the connectivity needs, including machine to machine, maybe even last mile connectivity as well. Enterprise communication is going to be a key part. And we are starting to see an interesting trend now of space-based communications and space-based data centers. And what matters in space is something that is smaller, lighter, and can communicate at very high speeds. And when you use the same technology that we built in space, you don't have to worry about any of the weather conditions. And because we do solid state steering, you don't have any moving parts. So we're seeing a huge pull coming from the space ecosystem as well.
Wonderful. So let's throw it out. I know a video will come here as well for what you built out. Big game days, are they going to be a focus as well? Like while Coachella is, let's say, a game day is it ready? Prime time ready?
Yes, it is ready. We started out. We didn't even realize this was a thing until we got called in by T-Mobile to do Coachella. Sorry, to do the balloon festival, which is almost 1 million people who showed up on a weekend in Albuquerque in the middle of nowhere, and they wanted to have 5G connectivity in the middle of nowhere. So we basically put our link in, and we provided very high quality 5G communication to them. Inspired by that, they did Coachella, which is the music festival, and then they learned how to use the product, and then they deployed it at the U.S. Open tennis tournament in Flushing Meadows, New York. And then after that, we didn't even know it, but then we found out later on that they deployed our link at the New Year's Eve Times Square on December 31st. How many of you here have good 5G access on your phone? How many of you are tethered to your phone and are running out of bandwidth? Exactly. And that is the thing that we could actually solve. You want limitless bandwidth, which is not congested, which is interference free, and is can provide an end-to-end ecosystem with light base, for example, with no speed breaks anywhere. That's the true experience that will truly enable this conference to the next level. And so that's the feature we want to build.
Wonderful. And see, from connectivity perspective, predictability, reliability, speed, big topics. How about cost per link? How is the cost factor looking like here?
Yeah. I think we have already started. This is space age technology, as I mentioned, right? And so obviously everything is super complicated. Everything is uh, unnecessarily driving the cost up. But when you fundamentally think at the end user and say, like, what are they willing to pay and look backwards, you need to redesign everything. So when I started the program, this product was probably, orders of magnitude higher, almost 500,000 or so. And we've been able to significantly bring down the cost to make it very viable to, if you were to dig or trench even a kilometer or two of fiber, this is going to break even. If you have to add 2 or 3 radio antennas, this is going to break even. And this is just the beginning point. Using that semiconductor based solution, it's going to dramatically come down the cost so that we can make this affordable into everything, not just a simple connectivity play, but probably into devices as well. And so that's really our goal, and we want to start driving the cost down significantly. And so far, we've been very successful in doing that.
Sure. So every technology has something to improve. So is there some adverse conditions that you need to work on as well, or you're working on to get better at?
Yeah, I mean, every technology has its own set of limitations. In the case of light based communication, anything that disperses light, so foggy conditions are a challenge, or heavy rains where you can't see the other side, that becomes a challenge. But it's just like having an umbrella. When it rains, you have an umbrella and you basically have some kind of a protective mechanism. We basically switch down to an existing RF solution or switch down to an existing fiber, which is unreliable also. That's okay, but hopefully combination of those two will be fine. And that's why we launched Lightbridge Pro, which is a carrier grade version with 5 nines availability, so we can easily do that switchover in a hitless way. So we can basically compensate when we will try and make sure that the link is up, but at some point if it is down, then we can switch down to another frequency and still be able to carry the critical traffic.
So the future I'll see is not about replacing radio, but augmenting it intelligently.
That is correct. Yeah. Think of it this way. You can instantly upgrade every single tower to 20 gigabits per second rather than being limited. Maybe the towers right around here are probably sitting on those microwaves. Those are all could be instantly upgraded to 20 gigabits per second or higher. That is the future that we're thinking of. And it's not a replacement per se, but it's a complement to fiber as well as to radio. No one solution can solve it all, but it's really how you actually combine them smartly to make it all work together.
No, I love it, and I'm enlightened today. So thank you so much.
Was that a nice pun there?
Questions from you guys?
Yeah, Mahesh, this FSO technology, right? I know some of the companies were working somewhere around 25 years back, right? But there were number of problems which had to be overcome, like scattering was one of them, right? Then always laser requires a line of sight, right? But certain things like the sensors which are sensing that, those were also very important, that whether they can sense laser at that speed or not, right? So what is something that did differently, because it has got a lot of acceptance now.
Yeah, we did several things to make the product work. In fact, I have a funny story. When we first deployed it in India, we saw the performance really bad. This was almost 7, 8 years ago. And when we went and visited the tower, there were monkeys on the tower, and they were territorial. Hundreds of these monkeys were just jumping around and swaying the tower. These laser beams are so narrow, like the size of a chopstick, pointing at a grain of rice several kilometers away. And when you have these monkeys jumping around, obviously you can't keep it focused. So what has happened in all of these past few years is we have advanced the silicon, the photonics, the optics, the manufacturability of it, the tolerance, and the sensors. So we now have an ability to compensate for all of that. We have a two-stage compensation mechanism. So we realize that we can solve by just shooing away the monkeys. We have to solve it in the product level. Because we can solve it at that one tower, and even those monkeys were territorial. They won't even allow us to get there until evening when they're all gone to realign the terminal. So now we basically have deployed these in such a way where the sensors automatically align. And so even if the wind blows or the tower sways, the temperature shifts, they can stay locked. They have also built software algorithms so that even if a bird flies through the path, we can detect it and retransmit so nothing happens to the bird. So we have done all of these improvements to make this technology commercially viable right now. And that's one of the key things that we have worked on.